Chakula! So, this video looks at how we write chemical formulas and name compounds for both ionic and covalent. Earlier in the week you learned how to deal with ionic all by itself and then covalent by itself, but you have to now distinguish between the two. So anytime you're given a name or a formula, your first step is to figure out if it's ionic or covalent. It's easy. If you have a metal or ammonium, which is NH4+ at the front end, the compound is definitely ionic. If all you see are two nonmetals, and you better know nonmetals are to the right of the staircase, if that's all that's present, then the compound's covalent. This provides a summary of your previous notes on ionic compounds. It reminds you name to a formula, you write the symbol and charge of the metal or ammonium. Do the same thing for the nonmetal or negative complex ion, and you crisscross the charges to form subscripts. Why? Because in an ionic compound you're transferring electrons, and the electrons have to be a whole number. It has to be balanced out. Once you have your subscripts, then you look to see, are they the lowest whole number ratio? If they are, you're done. If they're not, then you must divide to get down to the lowest whole number ratio. And remember, you do not write charges in formulas. They just become subscripts, they become numbers. We know the front end's positive, we know the back end's negative. And you only drop the brackets on a complex ion if there's a 1 outside the bracket. Formula name, you write the name of the metal or ammonium. Only write the charge if it's a multivalent metal. That means it can have more than one charge, appears twice in a box. You write the name of the nonmetal, it has "ide," or you write the complex ion name and don't do any changing to that. In many ways, covalent's a lot easier to deal with, but you can only use covalent rules for covalent compounds. For covalent, you're using prefixes. You write the formula of the first element, and its prefix becomes its subscript. You do the same thing for the second element. Again, prefix becomes subscript, no crisscross. Formula to name, you write the name of the first element, and then its subscript becomes its prefix. Pre means before, and you can always put a prefix in, but if it's the first element and it's 1, if it's a subscript 1, you don't have to put mono in. That's optional. For the second one, you've got to put in the element's symbol and the name, and you change the ending to "ide." You make sure it doesn't say chlorine, it says chloride. It doesn't say oxygen, it says oxide. Again, its subscript becomes the prefix, and the second element always needs a prefix. So now we have 12 examples somewhere, and I believe there's a page in your package that has this. If there's not, I'll have to post this. You should try doing this on your own before watching. This is just going to take you through the steps. But copying steps doesn't teach you. You've got to actually do the work if you're actually going to learn it. And of course you should know this from last year. So we look at copper 2-phosphide. Copper metal phosphide is a nonmetal. It is not a complex ion, so we know this is a binary compound. The 2 is there because copper is multivalent, and that's telling us it's 2+. Well, we know copper is a metal, so first thing is we put an I for ionic. Now we write the symbol for the copper. It's copper 2+, and the phosphide's 3-. We crisscross, and we're done. Notice, no pluses or minuses, just subscripts. If you write these numbers high, I get to mark it wrong, so don't do that. We're going to skip on over to number 4. I did these row by row instead of column. We look at that, it says ammonium, so we know it's ionic. Ammonium's NH41+, it's the top of your table of complex ions, and the only positive complex ion we deal with in this course. Oxalate is a complex ion, it ends in 8, that's a clue, and it's C2O4 2-. So we say, okay, crisscross the 1 and the 2, and we would have had a 1 come outside the C2O4's brackets. And since it's a 1, we drop the brackets. We have to drop the brackets. This is the correct formula. And we balance still the charges. Next one says lead 4. So we have plum bum 4. High V is 4. So lead's a metal. It's got to be ionic. There's our lead 4+. There's our chromate. And we crisscross. And we say, boy, that looks pretty nice, except we have a 2 here and a 4 there. So we can divide this by 2. We can divide the 4 by 2, and we get a 1:2 ratio. So this is not the right formula. Over here is the correct formula. Some of you might say, oh, I could do that just by inspection. I know it needs 2 of those and I could get there. If you can do that, that is absolutely fine. Next beast is covalent. Prefixes give a pretty good clue, as we see a di and a pent. But the fact that it's nitrogen guarantees it. Nitrogen is definitely a nonmetal. So we go boom, and we're done. N2O5. Di is 2, pent is 5, and we didn't crisscross or anything crazy. We look at sulfur trioxide. Sulfur, a nice yellow nonmetal. So it's covalent. SO3, it had no prefix, so it subscripts 1. Tri means 3, and we get our trioxide. Door number 6, we look at that. Aluminum is definitely a metal, so it's definitely ionic. We look up and find Al3+ on our periodic table of ions. And hydroxide, and I know it ends "ide," but it is a complex ion. So we find it as the OH-. And we do a crisscross. And a common mistake students make is they forget the brackets. The 3 went outside the bracket, so we gotta keep them. The 1 from here came down for aluminum. We don't write that down. So that's 6 more examples. By this point, you should have a clue how to do formulas. Come on. Now we're going the other way. We're undoing what we just did. So instead of going to a formula, we're coming from a formula to a name. And again, we have to say ionic or covalent. I look up AG, Argentina, and I say, aha, it's got to be ionic because silver is a metal. And I look at silver and I say it's not multivalent. So this is just silver sulfide. I don't have to tell you the charge. It's always going to be 1+. Here, this thing's going to split after the Ba, so we're going to have the barium here. Barium's group 2. So first of all, it's ionic. And we know barium is not multivalent. So this one is barium sulfate. So sulfide and sulfate are different. People say, oh, isn't that close enough? You mix those up. Things are going to be wrong. Do it right. You got the sheets in front of you. Come on. So door number 2, we see phosphorus at the front end. C for covalent. Phosphorus pentachloride. I could have said monophosphorus pentachloride, but you know, why put in the mono when I don't have to? Next beast. Definitely ionic. Gold is a very, very shiny metal, apparently worth something. And it happens to be multivalent. So when I calculate, that 5 came from the tripolyphosphate, the 3 came from the gold, so it's gold 3 tripolyphosphate. 2 more to go. I look at that and say oxygen. I know oxygen's a non-metal, so it's covalent. And I say, oh, don't bother with the mono. I'm just going to go oxygen difluoride. And if you misspell fluoride or fluorine, if you go O in front of you, I will mark it wrong. Why? Because it's on the sheet. Read the sheet. Bring your own magnifying glass if you have to, or borrow one. All right, door number 6. Here we have SN. Tin, we know that's a metal, so it's ionic. So get in the habit of classifying ionic or covalent. I know that's tin, I know that's sulfate. I know tin is multivalent. Uh-oh, that means I got to figure out the charge from the sulfate. When I look up sulfate on my table of complex ions, it's 2-. I have 2 of them. 2 times 2- means this whole beast is 4-. In an ionic compound, there is no net charge. So if this part's 4-, this has to kill the charge, it's 4+. So this is Dukes of Hazzard. That's a big tin 4 sulfate. And all of this stuff should be easy. You got lots of practice on worksheets. If it's not making sense, rewatch videos. Email me for assistance. Do something about it. You'll want to dominate the chemistry section. And if you can't name compounds, write formulas, you're going to have a real problem on the 4th section of chemistry. So we want you to build a nice solid foundation as we go. Enjoy.